Hello students, we're going to go over section 7.3. It's point estimates. So kind of looking forward to what we're going to be looking at. We'll kind of be looking back using the same mean, standard deviation. We'll be looking at those. We'll be looking as we go forward the type of data that we're looking at and looking and saying, is there a significant difference between what has happened and what has happened between two samples, what has happened between a population and a sample, saying is there a significant difference between them. So as we go through it, a point estimate is just a single number calculated from a sample data. It's used to estimate a parameter of the population. So that's just like, what do we want to know about the population? Do we want to know the height? Do we want to know the weight? Do we want to know the age? Do we want to know how much money they make? Do we want to know, we could look at the different races. We could look at different sexes. We could look at anything that we'd be interested in, their likes, what type of ice creams they like, what type of music they prefer. So those would be all point estimates. Okay, a point estimator is a formula or rule that is used to calculate that. So the idea, if I want to find the average, I add up all the numbers and divide by how many there are. So that would be the idea as we go through it. Okay, so some notation. Mu is for the mean, and so mean of the sample, and our standard deviation of the sample is theta. Just a reminder, x bar. Whoa, hold on. Here we go. Okay, we're also going to use x bar for our average, and that's the average of the population. So it's important that you understand these things as they go and so you'll see this quite a bit. You'll see mu, you'll see theta, that's for, sigma, you'll see sigma a lot. That's for standard deviation. We also use S for standard deviation. Again, this would be standard deviation of the population. Standard deviation of the population. So then what we're going to be doing is we're just going to be comparing them. So if I want to compare averages, so again, this is mu. If I want to compare the averages, I would subtract them. If I want to, the closer they are to 0, that means that they're not that far apart. If they are 0, that means they're the exact same. If I want to compare the variations, I divide them. So I set them up as a proportion. Okay, so I find the variance, and then we divide them and see what they are. The closer they are to 1, that means the closer they are to one another. So we'll go through. The following data describes the number of days trials last in big city and small town. Assume that the trial lengths are normally distributed. Okay, so it's saying, okay, we take the average, the mean is 5 days, and a standard deviation of 1. That's what we know the population is. However, we take a simple sample from big city and small town, and we want to compare them. So first of all, I need to find the average for big city and the average for small town. So the easiest way is just go to your sheet, and if I want to find the average, remember we just hit equals, and then you spell out average. Okay, and then you're going to go ahead and you're going to select all the values for it. Okay, so you find the average, and then end of parentheses. Just need to clear it up. So we get our average to be 4.3. You can drag it over. Should be able to drag it. Nope, not going to do it. So I'll just go ahead and do it the same way. So equals average. Spell it out. I find the average of it. Then I'm going to highlight the data. And I get 4.3, so it's 4.3 for big city and 3.7 for small city. Okay, so I come here, so it was 4.3 for big city and 3.7 for small town. That was the average. So then I find right here, it says subtract them, mu1 and mu2. So 4.3 minus 3.7. And we get, that's 0.6. Okay, remember we said the closer they are to 0, that means that they're more and more similar, they're closely related. If I want to find the standard deviation, or actually, so when it has here S1 squared, so anytime you see S1, this right here would just be standard deviation of one, standard deviation of the other. But then when they say S1 squared, so that whole thing, if I were to put it, what that whole thing means, so S1 squared, this just means S1 squared, that is your variance. So we want to know what's the variance of big city, what is the variance of small town. So we come over here to find variance, we just hit equals. And then we go var, VAR. And then we again want to find the just the column. So just those numbers. Oh, didn't like it, so we'll clean it up. So now we find the variance of it. We get 1.566. Okay, you could say that's 1.6, or you could say 1.57. Either way works. Then we're going to find the variance of this one. So equals VAR, parenthesis. Now we're going to choose all the values for small town. Okay, and we get 2.1. So 2.01. So we'll go 2.01 and 2.57. All right, so our variance is 1.57, and this one was 2.01. So when we go to the head, we want to compare these, so we're going to write them as a proportion. 1.57 divided by 2.01, and when we do that, we get 1.57 divided by 2.01, and we get 0.78. Equals 0.78. The closer it is to 1, the better it is. What do you notice about the ratio of the sample variances? Okay, so questions are going to be like this. What do you notice about the two means? So let's come up here. What do I notice about these values? Well, I notice they're not the same. They're not the exact same. They're a little bit different. And so I'd say that. It seems a little bit larger, not a huge increase, but there is a difference between them. They're not the same. So again, these aren't the same. They aren't the same. It could be that simple. Now, why aren't they the same? It could be because in big city, they take longer on their trials. Big city has more trials because they have more people. The population's bigger. So it takes longer to get through the trials because they have far more trials. Something like that. We look at the variance again. Are these variances the same? No, not the same. So again, the variances aren't the same. That's the idea as we go through. So this is what you're going to be going through and stating. It's going to ask reasons why they're not the same, and you could come through. They couldn't be the same because of population. They could be the same. There's natural variation. They're not always going to, in fact, they're very rarely will you have samples match up the exact same. So that's what you're going to go through and do on your homework. Your homework is that the worksheet to do.